To start off our next video, we will begin with our next physicist, which is Schrodinger. And he does everything that everyone before him does, is he builds on that information that he has, and he takes it one step further and mathematically creates locations and addresses of electrons. So he developed equations to incorporate both the wave functions, which we talked about earlier, and particle behavior. Sorry, that's a little sloppy. Of electrons. Now what this becomes is quantum mechanics. And we have a very simplified version. There's like a ton of calculus that boils into this that we don't need to worry about. But the idea of it is something that I think we can approach and understand fairly well once we get there. It's going to take a few lines and maybe even a couple lectures to get all the way through this, but we'll see. So what this does for us is it creates some orbitals, which you're probably familiar with a little bit, at least from last year, and these quantum numbers. And we're approaching this whole quantum numbers thing really as a kind of like a foundation. A college board should not be asking you any questions in regards to what quantum number is this or any of that. But it creates a foundation that helps us understand other things, I think, more easily. Okay, so we need some space here. I'll make a couple columns. We have column 1, which will be the principal quantum number. And we are probably more familiar with this as being the energy level, the rho. Underline it. The next quantum number is called the angular. And we would know this better as simply the shape. S, P, D, F. The third one is the magnetic quantum number. There is a fourth, which is simply the spin, but we're going to leave that one alone. And this is the orientation, kind of like the direction. We'll talk more about that as we're moving along. Okay, let's start building. So principal quantum, the letter designation for this is 1. And then, of course, we can have rho 2 or energy level 2. And I'll leave these alone for now. So we'll build on this in just a moment. The next letter, the designation we can put in here is L. And L is equal to, where should I put that? I'll put it over here. L is equal to n minus 1 or anything less than. So I could have put some more things in here, I didn't. N minus 1 or less. So for example, if n is 1, right, got it, 1, then L for n equals 1, L is going to be 0. And we call this shape, or in angular quantum number 0, we call that shape S. So the S sub level. Okay, Next one for 2, so we'll designate that. N is equal to 2. And for L, we still have 0, which we call S. But we also have 1. And for 1, we call that P. So the P sub-level. We have these options available to us. I'll come back over to here in just a little bit. I'm going to drag this across over here for 3. 3, okay, so N is equal to 3. And then we kind of get this repeating pattern. L would be equal to 0, or S could be equal to 1, or P. And if this angular quantum number is 2, we will call that D. And we'll keep moving this along. For 4, if N is equal to 4, L can be 0. So this is an option, it doesn't have to be. It could be 1, which is P, or it could be, getting off the page there, sorry, could be T, or finally, it could be, for 3, it could be F. And then we have all these other levels, but this will not change. There's some theoretical values, but we never talk about those. So to finish off principal quantum number 1, the energy level, it goes up to 7 on our periodic table. But for the angular quantum number, this is the end of the line as far as the sub-levels that are available within the principal or energy level. These 4 values will all be present within rows 5, 6, and 7. They will just repeat over there. There's no new ones that we can bring in there until we can expand on the periodic table, which that we don't see that coming. Okay, for the magnetic quantum number, let me pull back over to here. For the magnetic quantum number for that, the value that we can have is negative L all the way through positive L. Those are all available for this one. So over here, for L equals 0, I think I just got 1. And again, that's the orientation along the axis. Think X, Y, and Z, going in 3 different directions. It's spherical, so no, it just has one position. Just turn a ball, it doesn't change. It all looks the same. For energy level 2, focusing off the first one, it's still none, 0. But then here we have 1. So according to this, for L equals 1, we have negative 1, we have 0, and we have just, as far as the integers in between, and 1. So we have 3 different orientations possible for a P. So it can go along the x-axis, it can go along the y-axis, or it can go along the z-axis. Any of those 3 directions would work. And we'll repeat this over with energy level 3, same idea here. So we have 0, negative 1, 0, positive 1. And then we have 2, so why not? Negative 1, negative 2, negative 1, 0, 1. Put a little positive in there. And positive 2. And what you may be able to tell on the periodic table, and I'll pull one up here on the next lecture, is that these are the sublevels within each category. So for example, we can have 6 electrons in the P, and this eventually you can put 2 electrons in each one of these orbitals. So 2 plus 2 plus 2 gives us 6 boxes, locations in the P. The S has 1 location, so you can put 2 electrons in here. There's 2 columns over there. For the D, there's 10 blocks. I have 5 of these orbitals allowed, so we can put 2 electrons in each one of these, so that all works out. Let's fill in this last one here, and we'll call that the end of this lecture. So again, we have 0, we have negative 1, 0, and positive 1. and then -2, -1, 0, +1, and +2. And then let's call this -3, -2, -1, 0, +1, +2, and +3. So 7 locations or 7 orbitals, 14 potential boxes or elements, if you will, that are in any given row within the F block. Okay, there's a little bit more we can expand this, but I'll bring that up in the next lecture.